Good morning, everyone. Welcome to another Coffee with EMCSA. My name is Rob Walker. Today, I'm joined by a wonderful young lady who's making huge strides in the fields of e-mobility. It's great to see some of the next generation taking up the mantle and moving us forward. I'm joined by Ms. Frances Roux. Frances, thank you very much for taking time this morning to chat to us.
Hi, thanks so much for having me.
Fantastic. So, Frances, quick introduction. I know you've completed your Bachelor of Engineering at NNMU only a few short years ago. And you've also done an internship at the uYilo e-mobility program, which I know most people are very, very familiar with. Talk to us a little bit about yourself. Give us a little bit of a, dare I say, 3-minute elevator pitch about who is Frances Roux.
Okay, yeah. So as you said, I did my Bachelor of Engineering in Mechatronics at Nelson Mandela University, and during my final year, I did an internship at uYilo, and that is kind of where my e-mobility background started. So while I was doing my final year at uYilo, I also did my final year project, and the project was the development of a 14.4 volt 40 amp hour lithium-ion battery, which would kind of be a drop-in replacement for your current lead-acid starter lighting ignition battery. So that's where it all started out. And that stemmed into a master's degree. So that kind of sparked my interest in the field, and we carried on from there. And I started my master's degree in 2019, also for uYilo e-mobility program. So I stayed within the program while I did my master's, and my master's was titled Modeling and State of Health Prediction of Lithium-Ion Batteries Under Dynamic High Current Applications. So yeah, that's how my involvement within the field started. And while I was completing my master's, I had the opportunity to travel to Germany, and I stayed in Ingolstadt in Bavaria for 7 months, where I was part of an institute known as Charisma, and they also do some battery research and other automotive related research, but I was part of the battery team where we did some battery testing, destructive testing, and also just was able to be surrounded by other experts in the field. And then I came back home and completed my master's at the end of 2020.
Fantastic. So recently completed the master's, and I think in a very interesting field. I mean, talk to us a little bit about what is modeling, and more important, what is the state of health prediction of lithium-ion batteries. I understand, a lot of people are talking about this, especially with a lot of EV putting lithium-ion batteries in, and how do we predict the kind of the health. Give us a little layman's rundown of your masters, and what dare I say, what was the outcome? What was your hypothesis, and what was your conclusion?
Okay, so just to start at the beginning, or as you would say, a model of an actual lithium-ion battery, you get many different kinds of models, like equivalent circuit-based models or electrochemical models. I'm not going to go to too much detail, but there are many different researchers putting a lot out there for modeling. And the reason for this is that it saves a lot of costs and obviously facilities that are required to generate data when you're maybe trying to test batteries and also trying to build battery management systems or anything that would help with the monitoring and control of a battery. So to have that data by modeling is just largely beneficial. And that's why the masters had involved modeling, as otherwise, in order to develop my state of health algorithm, which I'll get into now, I would have had to run extensive battery aging tests. And so we were able to use Siemens SimCenter AIM-Sim software to use. They have pre-existing battery models, which I used within my research, and built a simulation of a battery similar to the one I developed in my final year project. We simulated dynamic high current aging of lithium-ion batteries. So we had a little simulation system set up which contained 4 batteries connected in series, and we had some control and circuitry, and that's basically where the model came in and why we had it. And then state of health of the battery is basically in a very simple terms to know where the battery is at in its life. Now with lithium-ion batteries, we know that we do sometimes run some safety risks maybe with elevated temperatures, or if one of the battery is damaged, there could be fire hazards or something like that. So I focused on having cells connected in series and being able to identify the weaker cells within the battery and seeing how does that affect the rest of the battery. So a lot of I don't know how maybe master's research works in other fields, but for us, you don't have to have like a specific scientific hypothesis. My research question was basically, can I develop and train a state of health algorithm using simulated data? And at the end of the day, I guess the answer was yes, with some reasonable, I can't think of the word now, like outcomes or limitations, that's the word, with some reasonable limitations when it comes to creating the algorithm using simulated data.
Okay, and so let's ask the question. I mean, so all this research that you've done, all this modeling, what does it mean for me, the man on the street who wants to buy an EV, and B, what does this research mean to me as the man on the street, so to speak?
Well, if you know that your EV that you could be buying has a state of health algorithm in it that has been well tested, well researched, then obviously you are going to feel much safer as the consumer. So it's not only about the state of health algorithm, but also how was it developed, how was it tested, and how much resources and energy was used to create the algorithm or to test the algorithm. Now, sure, any research company could use one set of battery data and then try different state of health algorithm methods, but usually you want your algorithm that you use is very specific to how you test your battery. So if you have if you have a simulation to do all of this for you instead of doing the testing, then you are contributing to the environment on a major level in terms of saving a lot of energy and resources for battery testing. So I think it can just largely, it's not going to directly influence you as the consumer in terms of reducing the cost of your EV or something like that, but you most definitely will be feeling safer knowing that there's been so much research put out there for state of health algorithms, as well as the fact that the data generated was done in an environmentally friendly way as well as an efficient way.
Fantastic. All right. So, I mean, that's really interesting. And I suppose it's people, young minds like you, doing all this research that helps moves the trend forward and keeps everyone going in the right direction. Let's talk a bit about, give us a bit of more detail or insight into what we can hear from you at EMCSA next year. A quick synopsis of your topic and what our viewers can look forward to hearing from you in March next year.
Okay, so I will be addressing specifically the influence of modeling and simulation of lithium-ion batteries on the EV sector, and also what influence it could make on EVs and their usage in South Africa. So I'm very much going to specifically be addressing modeling. I will also be just illustrating or showing a little bit of outcomes from my research and talking about what I learned from it, and also what I think could be addressed by other researchers in the future, and how we could maybe work together to make this more efficient and more useful for the industry. And then I'm not going to be focusing as much specifically on the state of health algorithm, but mainly on the influence of the modeling and the simulation on the industry, and just how it can affect our e-mobility sector in South Africa.
Thank you. And I mean, that sounds really interesting. I think that's key. That's key to kind of our discussion at EMCSA next year is localization. And I think that's so important. That we're doing our own research based on our own models and our own kind of input and data, because it's all well and good to get data and input from the Netherlands or America or Europe or wherever, but they have different environments, and as we know, the environmental influences such as the temperature, it all affects batteries and what we can expect in terms of performance. So I think it's key that minds such as yourselves who are coming from the academic field are doing local research, because at the end of the day, people need to feel confident that what they're getting from their manufacturer in terms of data and the mileage and everything is accurate for local conditions. It's great to say that, under ideal conditions, this is what the battery is going to do, or this is what my car is going to do. But we all know that ideal conditions hardly ever exist. So some real world modeling is fantastic. Before we close today and we let you go, because I know you're a busy young lady, any final thoughts, any kind of final bits of information that you'd like to leave with us before we let you go and get on with your Wednesday?
Nothing too specific. I'm just really looking forward to the conference and to hearing from everyone else as well. I am familiar and have familiarized myself with some of the other speakers, and I think it's going to be a fantastic conference, and I'm really looking forward to sharing some of my knowledge as well as hearing from especially fellow South Africans and just trying to see where the e-mobility is in South Africa. And I think it's going to be fantastic, and that we as researchers can come together and show that there's a lot that can be done within our country as well. Fantastic.
Well, Frances, it's been an absolute pleasure, and it's been really revitalizing and exciting to talk to you. I can tell that you're a young person, very passionate about what you do. So it's great to have people like you helping push the envelope forward. For myself, Rob, and the whole EMCSA team, thank you very much for taking the time again.
Thanks so much, and thanks so much for having me.
Absolute pleasure. So that was Frances from Frances Roux. She is a student, or she's completed her master's in mechatronics, and a very interesting study around battery health and around what she's done previously. And it's really exciting to hear that we're working with local modeling and how that influences what the consumer sees and buys. For myself, Rob, and the whole EMCSA team, thank you for joining us for another Coffee with EMCSA session. We hope you enjoyed this one. Thank you. Goodbye.